In this video, instead, we will look at the antioxidant activity of dairy products. Of course, by dairy products, we mean the softer ones, those that can also come into contact with water. An example is mozzarella. And right here, in fact, I have a sack of mozzarella with some mozzarella inside. Let's take two of them. And I'm going to open this mozzarella with scissors. So these are fresh mozzarella from the same brand, of course the same quality. So I'm going to put them here and drain the water. And so at this point we have the two mozzarella. What are we going to do? We're going to carefully select our water for this process. Here we have readily available tap water, which will be used to completely cover the mozzarella, ensuring it is fully submerged. And here, instead of pouring, I'm going to channel the water directly and precisely into the device, allowing for a more controlled and efficient filling process. The device is dispensing this water, and the water it's dispensing has a pH of 11.5, so it's super alkaline water, which means it's super antioxidant. Why do we use this water? Because we need to perform an antioxidant action on the mozzarella to allow the mozzarella to have an anti-aging effect, we could say, an anti-aging antioxidation effect specifically for the mozzarella. Because mozzarella, like any organic food, tends over time to lose its freshness, flavor, and quality precisely because it oxidizes. Using antioxidant water, as we have done here, as you can see in this container, means that the mozzarella will definitely have certain characteristics. And let's take a look at that now. Here is our orthometer. This is a tool that checks whether a liquid is oxidizing. For example, this is tap water. You can see that it is oxidizing, has a positive value around 260. On the other hand, this is a negative value, so it's even dropping down to -600 because this is antioxidant water. But the most interesting thing to assess is whether the mozzarella we're examining is oxidizing or antioxidant. Here we go. You see, this is a titanium probe, and I'm going to stick it right into the mozzarella. You can see that this mozzarella is oxidized. It has an ortho value of 230, so it's definitely a mozzarella that has undergone and is undergoing oxidation process. It's precisely these oxidation processes that make food tasteless. How many times have we eaten mozzarella and it seemed like it had almost no flavor at all? This might not be due to the quality of the milk or the production process, but sometimes it's also because of oxidation process. In fact, sometimes we've eaten food that's organic, certified DOP and so on, but the oxidation process still happens because from the moment the product is made to when it arrives at home, naturally some time passes. That time means oxidation, it means aging. In fact, that's exactly what I'm trying to show you. Now let's go back to the other mozzarella. I'll set up the orthometer here. You see, now I'm taking the mozzarella that's here in the other one, in the other container. Maybe I'll remove this piece that's left here. There's a piece of mozzarella left here. That's the beauty of live demonstrations. This proves that the video is done in one take, because I prefer not to cut the videos, since when videos are edited, understandably, those watching might suspect that things aren't being done as shown. In fact, as you can see, there's even a clock, precisely because the time is continuous and I never stop. So I've removed the mozzarella from the tip. Let's take a look at this mozzarella. Just a moment, I have two hands and it's not that easy. Okay, let's see. In the meantime, I'm skewering the mozzarella. Let's see. Look, the mozzarella is at minus 490. Impressive, isn't it? Minus 490. So what's the interesting thing here is the taste. And the taste here doesn't have much to do with the video, but having seen it many times, I've already done this experiment with chefs, professionals, but also with home cooks and people who are passionate about cooking, tasting this mozzarella and tasting the other one. I assure you they are two completely different things, both in texture and in flavor, precisely because the molecular hydrogen has entered the food and created an antioxidant effect. To prove that there is molecular hydrogen, this is an this is a molecular hydrogen meter. You can see it even says H2 meter. You see here, MH, it says H2 meter. Okay, if I put it here in water, the value will be 0, because this water does not contain molecular hydrogen. Do you understand? But here, if I put it here, you'll see that the value starts to drop, to rise here, and basically we have molecular hydrogen. It's precisely the molecular hydrogen, which is the smallest molecule in the universe, that is able to penetrate the mozzarella and thus provide these antioxidant properties. So the food becomes younger, the food becomes fresh again, right? It's as if it goes back to just after it was made, and in both taste and texture, this is clear, obvious, and it's truly an incredible sensory experience.